Today in MT5506L practical based on mathematical programming, we are reached to the practical number 10, fourth problem, practical based on B-game and two-phase method. So here we will solve one problem using two-phase method. Let your given linear programming problem be maximize z is equals to 3x1 minus x2 subject to constraints 2x1 plus x2 greater than or equals to 2, x1 plus 3x2 less than or equals to 3, x2 is less than or equals to 4, x1 and x2 are greater than or equals to 0. Using two-phase method, solve given linear programming problem. That is given your problem. Okay, so first of all, to move towards the two-phase method, first of all, we have to convert this problem in standard form. So the standard form of the given linear programming problem is that is obtained as problem will be as it is. So maximize z is equals to 3x1 minus x2 subject to constraints 2x1 plus x2 minus s1 is equals to 2, x1 plus 3x2 plus s2 is equals to 3, x2 plus s3 is equals to 4, x1, x2, s1, s2 and s3 all are greater than or equals to 0. This is your standard form. As you know that wherever greater than or equals to sign, we are introducing the surplus variable, and wherever less than or equals to sign, we are introducing the slack variables to get the equality in the sign. In short, in greater than or equals to sign, we are subtracting the positive terms from this side, and in the less than or equals to terms, we are adding positive term in this sign. So we are reached to this form. Now if we put x1, x2, x3 0, that means x1, x2 0, then s1 is minus 2, and that is not the feasible one. So we are doing, we are already seen this problem using B-game method, and you can solve this by graphical method also, but we are in this two-phase method, so we are introducing the artificial variable. So after introducing artificial variable, we have the following form of the given linear programming problem as maximize z is equals to 3x1 minus x2. Here s1, s2, s3 are there, but here it is not written, so we are writing it as a 0 s1, 0 s2 and 0 s3. So it is plus 0 s1 plus 0 s2 plus 0 s3. So 2x1 plus x2 minus s1 plus artificial variable is 2. x1 plus 3x2 plus s2 is equals to 3, and here it is x2 plus s3 is equals to 4. Again your x1, x2, s1, s2, s3 and a1 all are greater than or equals to 0. So the initial basic feasible solution is a1 is equals to 2, s2 is equals to 3, s3 is equals to 4 by taking x1, x2, s1 are 0. Okay. So now in the phase 1, see here artificial variable is there, so we have to write something about the artificial variable. What is its coefficient? That is not here, unknown. So we are writing as a phase 1. In that we will consider maximize z as Z star 0x1 plus 0x2 plus 0s1 plus 0s2 plus 0s3 minus artificial variables coefficient is minus 1, since our problem is of the form maximizing. So now we will write down the simplex table. So in the simplex table we are having CB, B, XB, X1, X2, S1, S2, S3 and your artificial variable A1. Their coefficients are, here it is 0, 0, 0, 0, 0 and minus 1. Now the coefficients in basis, right now we are having A1, S1, S2 and S3. So A1, S2 and S3. Their values are 2, 3 and 4. Now write down the coefficient from the constraints, that is 2, 1, minus 1, 0, 0, 1. And here it is 1, 3, 0, 1, 0, 0. And here it is 0, 1, 0, 0, 0. Sorry, here it will be 1 and here it will be 0. Now here coefficients are minus 1, 0 and 0. Now we evaluate Zj and Cj minus Zj to proceed as a simplex algorithm. So Zj's are minus 1 times 2, so minus 2, minus 1 times 1 it is minus 1, minus 1 times minus 1 it is 1, 0, 0 and minus 1. Cj minus Zj is 2, 1, minus 1, 0, 0, 0. So maximum value is here, so corresponding variable x1 will enter a basis. Now which variable is leaving a basis? For that we have to identify by replacement ratio. So 2 by 2 that is 1, 3 by 1 that is 3 and 4 by 0 it is infinite. So minimum value is 1, so corresponding variable a1 will leave a basis. Now we have to make this entry 1, this entry is 0 and this entry is already 0. So since artificial variable a1 is leaving a basis, so corresponding the terms will not be calculated. So our next simplex table is CB, B, XB, X1, X2, S1, S2 and S3. The coefficients are 0, 0, 0, 0, 0. In basis now we are having X1, S2 and S3. Coefficients are 0, 0, 0. To make this entry 1 we have to divide everything by 2. So we are having 1, 1, 1 by 2, minus 1 by 2, 0, 0. Now to make this is already 0, so we are writing that itself. So 4, 0, 1, 0, 0, 1. To make this entry 1 we have to subtract this from this. 3 minus 1 is 2, 1 minus 1 is 0, 3 minus half that is 5 by 2. 0 minus half is half, 1 and 0. So we are having this as a next simplex table. Now again evaluate Zj and Cj minus Zj. But see, observe that here all the coefficients in whatever variables is available, their coefficients are 0. So Zj will be 0 and Cj also 0. So Cj minus Zj is also 0. Whenever we are not having any variable, artificial variable in basis, in two-phase method in the phase 1, we are having all Cj minus Zj 0 at the end. Okay, so the phase 1 is complete. Now for the phase 2, first of all you have to think is your Z is the original one. Original problem Z was 3x1 minus x2. So here you have to write that one, 3x1 minus x2. Of course, coefficient of s1, s2 and s3 are 0. Okay, so all you have to do is write down this table again and make these coefficients this way. So let me write CB, B, XB, X1, X2, S1 S1, S2 and S3. The coefficients are 3, minus 1, 0, 0, 0 in basis. As now we are having, here it will be X1, so in basis we are now having X1, S2 and S3. The coefficients are 3, 0, 0. Table is same, so 1, 2, 4, 1, 0, 0, 1 by 2, 5 by 2, 1. Here it is minus 1 by 2, 1 by 2, 0, 0, 1, 0, 0, 0, 1. So we have made a copy of the table. Now we will calculate again Cj minus Zj. So for that, first of all, we have to evaluate Zj. So Zj is 3 times 1, it is 3, 3 times half is 3 by 2, 3 times minus half is minus 3 by 2, here it will be 0 and 0. So Cj minus Zj is 3 minus 3, 0, minus 1 minus 3 by 2. So it is minus 5 by 2, minus 1, sorry, 0 minus 3 by 2. So minus 3 by 2, 0 and 0. So positive quantity is for here only. So we are having this variable S1 is entering a basis. Now identified by replacement ratio which variable is leaving a basis. So 1 by negative, so it is infinite, minus 2 by half, it is 2 times, that is 4, and 4 by 0 it is infinite. So maximum value is minimum value is 4. So corresponding variable S2 will leave a basis, and we are having this entry as a key element. So we have to make that one 1 and these two entries 0. So again, applying the RRE process, we are having as CB, B, XB, X1, X2, S1, S2 and S3. Coefficients are 3, minus 1, 0, 0, 0. In basis now we are having X1, S1 and S3. And now coefficients are again 3, 0, 0. To make this entry 1, we have to multiply everything by 2. So here we are having 4, 0, 5, 1, 2 and 0. Now to make this entry 0, we just add these two rows. So we are having 1 plus 2, that is 3, 1 plus 0 is 1, 1 by 2 plus 5 by 2 is 6 by 2, so 3, here it is 0, 1 and 0. This is already 0, so we will write as it is, so 4, 0, 1, 0, 0, 0. Sorry, here it is 1. Okay, so now evaluate Zj's and Cj minus Zj. So let me write Zj. First of all, that is 3 times 1 it is 3, 3 times 3 is 9, 3 times 0 is 0, 3 times 1 is 3 and 3 times 0 is 0. Now Cj minus Zj. So 3 minus 3 is 0, minus 1 minus 9, that is 10, but with minus sign 0, 3 minus 0 is, 0 minus 3 is minus 3 and 0 minus 0 is 0. So all the terms Cj minus Zj are less than or equal to 0. Here Cj minus Zj are less than or equal to 0. So this is an optimal solution to the given linear programming problem with x1 is equals to 3, that is from here, and x2 is not on the basis, means its value is 0, and the corresponding value of z is 3x1 plus minus x2, that is 3 times 3 minus 0, that is 9. So the optimal value of z is 9, and we are reached to the optimal solution. Okay, so this is how we can solve a given linear programming problem in via two-phase method. We already have seen that we have just solved this problem as via BGAM method as well as graphical method. Today we have seen again it as a two-phase method also. Okay, so write down this. The volt reticle is complete. Reticle number 10 is complete. Write down in a A4 size papers and stay at home. Stay safe. Thank you.